Okay, let's look at this problem. The chemical 1,4-dichlorobenzene. Okay, 1,4-DCB. Well, if you want to draw a benzene ring, it will be like this. This is a benzene ring where there's a double ring here, a double ring there, and a double ring here. When you say 1,4, so this is point 1. So at point 1, there is a chlor because dichloro. 1, 2, 3, 4. So here, 1,4, point 1 here, up. Okay, and there is a benzene ring, but there's a double ring here. So 1, 2, 3, 4. So 1,4, because the chlorine adds at 1,4, di-2-chlorobenzene. So this is 1,4-dichlorobenzene is sometimes used as a disinfectant. Of course, we clean up with it. It will kill all the microbial life in public lavatories, in public bathrooms. They clean up everything in public bathrooms to make sure that all the microbial life is killed. At 20 Celsius, 68 Fahrenheit, the vapor pressure is 5.3 10 to the minus 5.3 10 to the minus 4 atmospheric. Number 8. What would be the concentration in the air in units of gram per meter cube? So he gave it to you in atmospheric, and he wants in gram per meter cube. I solved this already. So 1,4-DCP, 1,4-dichlorobenzene, the vapor pressure is in atmospheric. Remember, vapor pressure higher vapor pressure mean high volatility. Okay? So he want to find it in gram per meter cube. Now, to change it from atmospheric to gram per meter cube, you have to use the ideal gas law, BV equal nRT. Remember, V is liter and N is mole. So we're going to find mole per liter, and then from this we could work it out to gram per meter cube. So N over V, here it's wrong. N over V. So see, typing error. N over V is equal B over RT. So the pressure is, this is the vapor pressure, and R, of course, we know this is the R that we used a lot, in liter atmospheric per mole Kelvin, and the temperature is in Kelvin. So 20 plus 273, and that is 293 Kelvin. So Kelvin with Kelvin, atmospheric with atmospheric, you're gonna get mole per liter, and that is the concentration in mole per liter. But that's not what he want. He want gram per meter cube. Now we have to put it here. Again, mole per liter. He also gave you the molecular weight of 1,4-DCB, 147 gram per mole. Now, if you multiply it by the molecular weight, you can see mole will cancel out with mole. You will end up with gram per liter. Now you convert liter to meter cube because you want it in meter cube, remember? So 1 meter cube is equal 1,000 liters. So now liter with liter, now you end up with gram and meter cube. So the answer would be 3.2 if you multiply 1,000 times 147 times 2.2, 10 to the minus 5. 3.2 gram per meter cube. So the first part is solved. Now let's look at the second part. An alternative disinfectant. There is another one, not 1,4-dichlorobenzene. There's another one that's being used in some public lavatories. 1,4-CB, 1-bromo. Now let's draw this benzene ring too. Okay, so I'm going to have a double ring here, a double ring here, and a double ring here. And look at this. 1-bromo. 1-bromo. So this is 1. So I'm going to have bromine. 1-bromo. 1-bromo, 4-chloro. So 1, 2, 3, 4. So here there's chlor. So 1-bromo, 4-chlorobenzene. That's it. This is it. That is the 1,4-Cp. Now, here he gives you that the boiling point of 1,4-Cp is 196, while the boiling point of 180 is what? The 1,4-Cp is 180. Now the point is, okay, the question is the following. Which compound would cause the highest concentration in the air in laboratories? Which one of these two compounds will have the highest concentration? Will volatilize easy. Okay? Of course, the one with the higher vapor pressure will volatilize easy. But also, we should look at this and find out that if you boil it if the boiling point is very small, it means that also in chemical analysis that it will volatilize quicker, easy. It will be found at highest concentration in the air. So the answer to this, that the chemical with the highest air concentration would have the lowest boiling point. So 1,4-DCB will cause higher concentration in the air. Okay, so 1,4-DCB, not 1,4-CP, not this one, this one. Okay, the 1,4-dichlorobenzene, because the boiling point is very small, and because the boiling point is very small, it will have higher vapor pressure than the 1,4-CP, so therefore it will be found at higher concentration in the air and, of course, public laboratories.